So Google Gemma 431B. It just dropped and apparently it beats everything in its class on MMLU Pro. Is this spec sheet flex or an actual breakthrough?
Breakthrough, but not the one they are advertising. The real story is that a dense 31B model just outperformed a MoE variant that runs at nearly 4B parameter speed.
Wait, that does not make sense. A MoE model that activates 4B parameters should be more efficient and competitive with a dense 31B. How is the dense model winning on accuracy across nearly every benchmark?
Different training recipe. The 31B scores 85.2% on MMLU Pro versus 82.6% on the 26B MoE, and 89.2% on AIME 2026 versus 88.3%. The limitation is not the architecture. It is that the dense model requires a single 80 GB GPU, while the MoE variant fits on much smaller hardware.
Oh, so you're not saying the MoE variant is bad. You're saying that dense 31B just made the compute versus accuracy trade-off more complicated for every developer choosing a model right now.
That is what scares the inference providers, not the technology. The shift in how buyers will evaluate which model to deploy when a dense model outperforms a MoE at realistic hardware levels. Google S31B dense model just hit 89.2% on the hardest math benchmark on the planet. That number should not be possible at that size. But it is real. And the story is not the number itself. The story is that it beat a MoE variant that runs at nearly 4B parameter speed. Most people expected the Gemma 426B MoE variant to win this fight. Activating only 4 billion parameters, it runs nearly as fast as a 4B model. The 31B dense version was supposed to be the slower, bigger option for when you had the hardware. Nobody expected the dense model to beat it on nearly every benchmark. On MMLU Pro, the 31B scores 85.2% versus the 26B MoE at 82.6%. On LiveCodeBench v6, it scores 80% versus 77.1%. On GPQA Diamond, it scores 84.3% versus 82.3%. On Codeforce's ELO, it reaches 2150, a level the MoE variant cannot touch at 1718. But here is what nobody expected. The previous generation Gemma 327B scores 67.6% on MMLU Pro and 20.8% on AIME. The new 31B hits 85.2% and 89.2% on the same tests. That is not an incremental improvement. That is a generational leap in reasoning capability that makes the prior flagship look like a different category. The architecture is a dense transformer with hybrid attention that interleaves local sliding window attention with full global attention, ensuring the final layer maintains full context awareness. The 26B-A4B is a mixture of experts model that activates 3.8 billion parameters per token, but totals 25.2 billion parameters. Both share the same 262K vocabulary and are Apache 2.0 licensed. The 31B model fits on a single 80 GB GPU and BF16. The MoE variant runs at near 4B speed, meaning you get 82.6% MMLU Pro performance with a fraction of the compute cost. For developers choosing between them, the trade-off is stark: maximum accuracy on the dense model or maximum efficiency on the MoE variant. Community quants are already live from the Bloke, Murdermacher, and Bartowski. The model runs natively in VLLM, SGLang, and transformers with no custom kernels or code forks. The Apache 2.0 license means you can use it commercially without restrictions, which matters enormously for local deployment use cases. Early in the development cycle, people assumed that MoE architectures would dominate at the 30B class because of the compute efficiency advantage. The Gemma 431B proves that dense models can still win on raw performance when the training recipe and data quality are strong enough to justify the extra parameters. If you are running a local coding agent, a reasoning assistant, or a vision language pipeline on a single GPU, the choice just became more complicated. The 31B dense model outperforms the MoE on nearly every metric, but the MoE variant runs faster. Your decision is no longer about which model is better. It is about which trade-off matches your workflow. The assumption that smaller active parameters always win on efficiency just got challenged by a model that beats a MoE variant on accuracy and runs on standard inference infrastructure. That assumption will not survive the next generation of dense models.
Yeah, that one is going to take a few days to sit with. If you want the next breakthrough before everyone else does, you know where the subscribe button is.